This is the video for Unit 6, Lesson 1, Graphing Exponential Functions. The goal of this is going to be to identify key features of an exponential function and also to graph an exponential function. Just kind of a refresher from what we've seen in Math 1 and Math 2. Remember, an exponential function is in the form of a times b to the x, where a and b are constants. And when we're thinking about a times b to the x, remember a represents our y-intercept or our initial value or our zero term. B is what we a lot of times call our growth factor, or this is our common ratio. And essentially, it's what we multiply by to get to the next term, right? And we always think about it in terms of multiplication. So if let's say I'm dividing by 4, it would be the same as multiplying by 1/4. So a couple properties we have with that: when our ratio or our growth factor is greater than 1, it's going to be an exponential growth, or it's going to be an increasing graph. When our b value is less than 1, it's going to be an exponential decay, or we'll say that it's decreasing, right? So our a and our b are going to be what we kind of use to a lot of times start our graph, start our table, and then eventually we're going to add some transformations to that. So for example, if I have f of x equals 2 to the x, and again, that's the same as y equals 2 to the x, I don't see a value in front, so it's like there's a 1 there. So my a value is 1, my b value is 2. So again, what that means in a table is that my y-intercept is 1, so that's in this case matching my a value because I don't have anything moving it from left to right. And then our common ratio is 2, so that means I'm multiplying by 2 to get to my next value, right? This exponential function of 2 to the x, you can see it has some properties we've hopefully have seen before. So we see that domain is going to be all real numbers. For our range, we're going to see it actually has a horizontal asymptote, right? So when I go to the left, it's going to keep getting cut in half, but it's never going to dip into the negatives. So it is going to have a horizontal asymptote at y equals 0. In our range, it's going to go from 0 to infinity. So it's never going to dip below 0, but it's also never going to touch 0 either. The y-intercept for this one is just simply our a value. Again, we don't have anything moving us left, right, up, and down, so we can just read it right off there. So it's 0, 1. And then our end behavior, as x goes to the left and x goes to the right, what's happening? If we look at the tail ends, for the left side, you could see it's starting to approach 0, right? When we go to the right side, it's going upwards. For this one, we would write when it goes left, it's going to 0. When it goes right, it's going to infinity. So the first section we're going to look at is just identifying our key features, right? So we talk about growth and decay. Again, growth is when we have a b value that's greater than 1. Decay is when we have one that's between less than 1, or between 0 and 1. And we can see that from the graph also, when we go from left to right, is it increasing or is it decreasing? So in this first example, when I go from left to right, I can see this graph is increasing. So it's going to be a growth, a circle growth. The domain and range looks just like what we just saw above, from negative infinity to positive infinity. My range, it's going to go from 0 upwards. And then it has a horizontal asymptote at y equals 0. The end behavior is also going to look like what we just did. So when I go left and then I go right, on the left end, you can see it's going to 0. On the right end, you can see it's going upwards. So I put 0 and positive infinity. For the next example, same thing. So when I look at my graph, when I go from left to right, I can see this one is decreasing. So it's going to be a decay. The domain is always going to be all real numbers. So negative to positive infinity. But my range, you could see the lowest it hits is actually negative 3. So my range is going to be negative 3 to infinity because it opens up. And you'll see there's a connection with our range and our asymptote, kind of like we saw with the last one. So I actually have a horizontal asymptote at 3, it's never, or negative 3, it's never going to dip below negative 3. For our end behavior, this one might look a little different. So the first one's saying what's happening at the left tail. The left tail, it's going up to positive infinity. What's happening with the right tail? The right tail, it's plateauing off to negative 3. And that would be it. The U tries will have U try out. And then the next part we're going to do is graphing. So you can use your graphing calculator if you like. This is just going to walk through, reminding you how to graph with a table. If you wanted to use a table of values, and hopefully this is something you remember from back in actually Math 1 and Math 2. So for this one, we can see that these are in the form of a times b to the x. So we don't see anything subtracting the x or subtracting from the function. So this is kind of like what we're considering kind of like a parent function. It's not quite a parent function, but this is kind of our baseline we're using to graph before we ever do anything extra. So in this first one, I don't see a value in front. Our a value is 1. And our b value is 1/3. So I'm going to go ahead and just list some values here. You could have listed different x values. I'm just going to list just for consistency, negative 2 to 2. So right away with an a value of 0 or a value of 1, I know when x is 0, y would be 1. And then we also know that our b value is how we multiply to get to the next term. So if I do 1 times 1/3, I would get 1/3 or 0.33. If I multiply by a third again, I'd get 1/9 or 0.9 or 0.11. Right? Multiplying by a third is just the same as dividing by 3, right? So it's like if I did 1 divided by 3, I got 0.33, and then if I did 0.3 divided by 3, I got 0.11. If I reverse the process, right, I'm still multiplying by a third to go down the chart. So to reverse it, I would have to multiply by 3 over 1. So 1 times 3 would be 3. 3 times 3 would be 9, right? So it continues that same pattern where I'm dividing essentially by 3 each time. Now that we have our table, we're going to go ahead and plot. So we have here negative 2, negative 2, 9, negative 1, 3, 0, 1, and so forth. And that would be our graph. So you can see that when it's actually going to be a decrease or a decay, we didn't have to even graph it to see that it's less than 1. And then it has all the features we talked about earlier. The second one is kind of the same thing, right? So I see it's in this a times b to the x form. Our a value, if I go ahead and put this in, if I put our a value is negative 3, our b value is 2. When we put 0 in, we're going to get negative 3. And then we're multiplying by 2 each time. So if I multiply, I'll get negative 6. If I multiply, I get negative 12. And then to move up the chart, you do the inverse, which would be dividing. So this would be negative 3/2 or negative 1.5. And this would be negative 3/4 or negative 0.75. So now if we were to go ahead and graph this out, negative 2 and negative 0.75 would be somewhere down here. Negative 1 and negative 1.5 would be in that third quadrant. We have 0, negative 3. 1 on negative 6. And then 212 would go off the graph. So we have something that looks like this. right? So a couple of things we're going to notice. So this one, even though it's a growth because it's a 2, the -3, you could see that negative reflected it down, kind of like we've seen with other transformations. So that A value still changes the shape, right? The 3 essentially makes it a stretch because it's bigger than, the absolute value is bigger than 1. The negative means that it's reflected, kind of like we've seen in last semester. And then it's still doing all the other properties. So if you have any questions, please feel free to ask me in class, sign up for T-Bolt time, or go to the center.